Today we will see combination of resistors. It's a 10th standard and 12th standard topic. Combination of resistors. Physics. Actually, resistance we connect in series as well as parallel. Suppose we connect 3 resistors in series across potential difference V. And let's say here we have R1 resistor, here R2 and here R3. Now we have to derive an expression for series combination. What we do, how we start it. Suppose this is battery, from here current is coming I. Now the I current will enter in this resistor and then this, then this. So we can say first thing that in series combination current is same. Current is same. So when we solve numerical, which is a combination of series and parallel both, there sometimes there is a confusion to check whether it is series or parallel. So whenever any resistors are in series, the best method is we have to check that whether current is same or not. Here we can say that if I current is coming out from battery, the same current will go to R1, R2, R3. So current is same. If current is same, then what about potential difference? Here potential difference across R1, let's say V1, R2 V2 and R3 is V3. Now, can we say that potential difference across battery, that is supply voltage, is equals to this V1, V2, V3. V1 plus V2 plus V3. Supply voltage, total voltage is equals to sum of all the voltage. So V equals to V1 plus V2 plus. Now in last class we have seen that Ohm's law, V equals to IR. So in place of V we can write IR. Which R? This is a question. This R is R equivalent. What is R equivalent? R equivalent is if we want all 3 resistors in one, like we can draw one resistors like this, and battery we say R equivalent. Means instead of this 3, only one resistor, that is R equivalent, is equals to V1 equals to I1 R1, V2 is I2 R2 and V3 is I3 R3. Now current is same in series, we know, so we can say that I equals to I1 plus equals to I2 equals to I3. So all current is same, so we can write IR equivalent is equals to I R1 plus I R2 plus I R3. Now IR equivalent is equals to I, you take common because it's equal, current is equal, R1 plus R2 plus R3. Now I cancel, so R equivalent in series is equals to R1 plus R2 plus R3. This is expression for equivalent resistor in series. Now, how they ask question? Very simple. They are, suppose they give 4 resistors and they ask what is, suppose you have 4 ohm, 5 ohm, 6 ohm, 10 ohm. They ask what is R equivalent. So R equivalent, first we have to check whether it is in series or parallel. We can say that same current is passing through this. So R equivalent equals to R1 plus R2 plus R3. So 4 plus 5 plus 6. 4 plus 5 plus 6 plus 10 ohm. That is nothing but 9. 4 plus 5, 9. 9 plus 6, 15 plus 10, 25 ohm over. So in series, we can, if they ask only series, very simple, R1 plus R2 plus R3, like that. If we have 4 resistors, we can say all. If we have n resistors, suppose this R1 plus R2 plus R3 n times, okay, R1 plus R2 plus R3 plus R4, like that. Now, what if we have resistance in parallel combination? Suppose we'll take only 2 resistors, R1 and R2. How to prove this? How to get the expression for that? Very simple. Here we say that voltage is V. Now, here potential difference is V. Now, here across this 2 resistors also potential difference is V only. If you have any doubt in understanding potential difference, what you can do is, you consider that potential difference is V, means here V, here 0. Yeah, potential difference is V. So this wire, there is no resistance. So here no resistance, no resistance. So till here is V only. Here also is V. Here also it's V. Here also it's V. So this two end of resistor is connected with V. And here 0, here 0, here 0, here 0, here 0. So here also 0 and here also 0. So these two resistors are connected across the potential difference V. Because here also V, here 0, here also V, here 0. So both are connected with same potential difference. So we can say that in parallel combination, potential difference is same. So what? How to derive that expression? We can say that if current is coming out I here let's say I1 and here let's say I2. In this case, current is distributing but potential difference is same. So how we start? We write current equals to I1 plus I2. Whatever current is coming out from the battery, that only is getting distributed and coming back to the battery. So I equals to I1 plus I2. Now, again we have to use Ohm's law. I said this is the soul of this chapter. V equals to IR. So what is I? V by R equals to I. Now, V by R. Which one? R equivalent parallel. V equals to I1 equals to V1 by R1 plus V2 by R2. But what we know? V equals to V1 equals to V2. So instead of V R equivalent parallel equals to V by R1 plus V by R2. Now V take common. So if you take common, what will happen? 1 upon R equivalent is equals to 1 by R1 plus 1 by R2. V will get cancelled. So this is the formula of R equivalent. Here only, let's say R1 value is 5 ohm and this one is 10 ohm. So how to find? Using this formula, we can say 1 upon R equivalent is equals to 1 by 5 plus 1 by 10. So how much LCM is? 10. 2 plus 1. R equivalent, we got 10 by 3, because this is 1 upon R equivalent. So R equivalent is ulta, reciprocal of this, 10 by 3 ohm. Right? Let's see one more question based on this. Suppose any question, I can frame many questions based on this. Suppose we have this question. This is 2 ohm, 3 ohm and 5 ohm. Suppose there is a voltage potential difference 20 volt. Now how to solve this question? You can try to solve this question. First tell me, is it parallel combination or series combination? We can say that it's a, you can say this question how to solve. Is it series combination or parallel combination? Yeah, it is mix. It's series and parallel both. How to solve in exam? This question only comes. What to do here? Here 20 volt, here 2, 3, 5. First, our trick is that you start from battery. Here current is coming I. Current is going. Yeah, here current I1 and here current I2. Now current is distributing, and whenever current is distributing, we cannot say that all three are in series. No, never. Because here current is something, here current is something. But one thing we can say that this one, this resistor, 2 ohm resistor and 3 ohm resistor, in both of this resistor current is same. That is I2. So we can say that these two are in series. If these two are in series, so what is R series? R1 plus R2. So R series is equals to 2 plus 3 ohm. So R series equals to 5 ohm. Simple. We got this. Now, when you solve this, next moment what you have to do, you have to draw equivalent circuit where you have to use this. So what you can do, write 5 ohm here. Instead of this 2, write 5 ohm, and here also it's 5 ohm. Now what to do? 20 volt here, 20 volt. Now what to do? These two are in parallel. So 1 by 5 plus 1 by 5 are equivalent. 1 upon R1 plus 1 upon R2. So 1 upon R1 equals to, here LCM is 5. So 1 plus 1. So 1 upon R equivalent. What is R equivalent? 5 by 2. So we got 5 by 2 ohm is R equivalent. Now we got R equivalent circuit we can draw. This is total R equivalent is 5 by 2 ohm and voltage is 20 volt. Now we can find total current also. So V equals to IR, we know. V is 20, R is 5 by 2, I. So what will get I? I is equals to 20 into 2 by 5. So 5 4s are, I equals to 8 ampere. So 8 ampere current is flowing from the battery. Now I will give you one homework you can do. That if 8 ampere current is coming from here, battery, let's say here 8 ampere. How much is going, what is I1 and I2 you have to find out. How you will find I1 and I2? You have to use this circuit. If you use this circuit, equivalent circuit, you can find how much current is going here and here. Okay, I hope it is clear. Thank you.